because it changed and then I didn't change it back. All right. So just hoping that you get into the groove and seeing that some of the questions might look a little bit different, but we've already got the skills to do a lot of this stuff. So if we look at the first one, just pop that in, and I put them in random orders. So we see we're not quite happy. We've got C and C over 2, and I know a lot of you might be going, well, that's just a whole C plus half a C. So that would be 1.5 C, right? But sometimes there might be just yucky numbers, so we're going to go and just stick with our normal. Oh, now I've got my touch and my pen come back. Ah, it's updated. So remember how we did this before? We said it was C over 1 plus C over 2 equals 12. And I don't want to confuse you, but one of the things you can do when it's simple like this, you could just, don't like that divide by 2, Hames, so how could I get rid of it? Just times everything through by 2, right? Now, watch before you write. So if I times everything through by 2, I get 2C plus C equals 24, right? However, sometimes when people do that, they might miss a step and they might not times everything through, or they might end up timesing this twice. So what I recommend when we're starting, we're going to go back to what we were just doing before, and we go, well, I'm going to put this as a common denominator. What did I times 1 by to get to 2? So what I do the bottom, I do the top, so we get 2C. That's already got that denominator. We get 12. How do I get rid of the divide by 2? Times. Bang. So as the questions get more complicated, so I'm just going to say that again. A lot of you could look at this and just go, yeah, I can see that. I'm just going to times through by the 2. And if you're happy to do that, you go straight here, all good. If they're more complicated questions, sometimes it might not just be a C, it might be a C take 4. Ooh, shouldn't say C4. It might be, instead of a plus here, there might be a multiplication there. So things might get a little more complicated. So if you're unsure, your step is to always add an extra process. So we are going to get some more tricky problems, but you can see how it works. Can we all solve it from here? 2C plus another C. 3C. I'm answering yours, Hames. Hang on. And you can either say, yeah, 3/8 are 24, or get rid of the times 3 divided by 3. My friend.
I was thinking.
You were thinking.
Times by 2.
If you just times by 2.
To the other side to get rid of it.
Yeah.
And then it was C plus C equals 24. Wouldn't that speak?
So this is why. So okay. Did everybody hear what Hames said? Why couldn't we just times by 2? And you would have had C plus C equals 24. Now that would actually then be wrong, because when we're timesing, we're getting rid of this divide by 2. We have to times every term by 2. So that's why I was showing you that step there, which you can clearly see. Get them as the same denominator, and that becomes 2C, not just C. So you've got to make sure you're timesing every term by that thing. So if you want to do that, pop on down. We are getting to the point where sometimes at the bottom it's not going to be a 2. It might be a x plus 1. But it won't bother us because it's the same process over and over and over again. Okay, so now we've got our little friend over there. Do I need to pause? Everybody got that one down? You should recognise some of this stuff. If I just covered up that equals 6, this was stuff that you were doing before, right? So we're going to do exactly that. We're going to ignore that equals at the moment, and we're just going to go, oh, I thought I changed colour. We are going to go, why is I gone? Too many things coming up. What? Why is it not changing my colour? I don't know. Anyway, so what's a number that 3 and 4 both go into? Correct. So we pop the 12 there. And what did I times 3 by to get to 12? So I have to do the same. So again, if you want to say times 4, do so. But do make sure that you're using your brackets. We've got the minus. And what did I times? Yep.
Do we have to use the brackets if we know what it is?
It's up to you. Okay, and what I'm going to do now is I'm going to expand my top brackets. But at the same time, I'm going to say I can get rid of this divide by 12 by timesing by 12. So is everyone happy that I can do that? I'm not happy that my colour's not changing. Okay. I did try the other one. Oh, come on. You saw me try the other one before. Come on. It's got the... hasn't even got the pen there. I don't know where my pen's gone. Oh, pen's that side. Okay. So we're going to go 4m plus 8 minus 3 times m is minus 3m. Negative times a negative. And, you know, you just asked, Aiden, can we just put it straight away?
You'll be happy to know it's the same thing.
Yes, if you can, that's fine. You're just minimising your errors, especially if this is late on Thursday. We're thinking of, we want to go home. And yes, we've got Angus. Do that again, Angus.
What?
Do that again.
I'm not going to moan into the microphone.
That was a big moan. You're sitting right next to me. Right, so again, depending on how many errors you make, whatever, you're either going to put it over 12 or, notice, I'm timesing up by 12. Okay? People who are trying to work quickly, right at this point up here, they could have just gone, I'm timesing everything through by 12, and they get to this line, but guess what? I see so many errors, it's not funny. Can we then finish from here? We're good? Gather your like terms. 4m take 3m is m. 8 plus 15, last time I checked, was 23, equals 72. So for the next few questions that we're going to be doing, I'm going to get to this, and I'm not going to carry on and finish, because I believe once we get to this, we're confident to finish. So the whole point is, how do we get to that row there? So this is the last one I'm doing. What's 72 take 23? Oops, you can't see that. I just said we're not going to solve this one in yellow for a specific reason. We're just going to do one step. Correct. We should know what we can do after that. So what's the first thing we're going to do to make our life just a little bit nicer, Micah?
You're going to take the fraction and put the denominator.
Right. We're going to remember from last lesson that this is actually x plus 2 all over 3. Minus, and this one will be minus 2x take 1 all over 5 equals 5. Now, is that not very similar to what we just did before?
Yeah.
So, remind me, what would we do? Common denominator. Once again, what you could do is times through by 15, but people will make a mistake with that negative there. So, this is why I like us to just slow it down a bit. Do the 15. Yes, yes, yes. Times that by the 5, so put that there. What did I times 5 by to get to 15? It was the 3. Our books are looking beautiful and neat because we're doing so much work, but not really. We're just copying stuff down. Now, Aiden, what would happen next?
You'd expand.
You would expand the brackets. Now, I'm not getting there. We would expand the brackets. Would I write the denominator?
No, because you can put it onto the other side.
So that was a no. I can put it onto the other side. And when you say put it onto the other side, you are saying you are multiplying, timesing it, correct. Okay, so this is where we'll probably stop now, because yes, we can expand. If these are your notes, do you know what? I'm not even against you writing expand equals. Oh, come on. 5 times 10 is 50, and 5 5s are 25. And for those of you who watch 8 out of 10 Cats does countdown, what does John tell you? You've got to know your 75 times tables. And if you are watching that, you shouldn't, because it's a little bit naughty. It's M. It is. Right, I just heard an oh God, and I was about to ask, let's be honest, who's a little bit intimidated? Love the faces. Who's a little bit intimidated by these questions that are on the board now? Correct. Excellent. Okay, so we're not alone. However, we're just going to do a couple of simple steps and then becomes, yeah, hopefully. You tell me if I'm incorrect, you tell me. All right, so I'm a bit over the green. Let's go blue. Now, like we did with the fraction stuff, we dealt with common denominators, we did the top, we did the bottom. Here, we're going to look at the left-hand side, then we're going to deal with the right-hand side, okay? So if we look at the left, what is it that's screaming out to you? So just keep your eye on the prize on the left. What are you thinking? Jess? Jessie, 3 and 10, what are we thinking? We are thinking 30. Oh, it's like you're a mind reader, okay? 30, so it can't be 15. What did we times 3 by to get to 30? 10, so we're going to do the same to the top. So those are the same rules that we have always used and will always use. Thank you. What did I times 10 by? 3, so I've got to do the same. Ooh, nearly dropped the pen. I've got to do the same to the top. Left-hand side, done as much as we can. Right-hand side. Excellent. 2 and 4. I will be honest with you, I was just in the zone then and I was about to say 2 times 4 is 8. Now, I wouldn't be wrong, but it's just going to be not the smallest possible. So, okay, how do we deal with this? Well, 2 times 2 gives me 4, so I've got to do the same to the top. We leave that because it's already over 4. So technically that's by 1, that's by 1. Pausing. Question, can I add the 20g and the 3g? Yes. Absolutely. So that becomes 23g over 30. I'm a bit disappointed that there wasn't anything I could cancel there. That would have been nice to make everything smaller, but that's okay because we use the lowest. Can I add the 2 and the 3g? No. No, and I can't cancel anything either. Good. No. Okay. And now, what are we going to do?
Would it be beneficial?
Now, we're in the age of calculators, right? And you can just go, I just don't want to make too messy. So what you could do is you can easily just cross multiply. Okay, so you could go, well, 4 times 23g equals 30 times 2 plus 3g, and go on your merry way and solve. Get your g's on one side. Happy with that? Get rid of the times, you divide and so on. You could, if you wanted to, go, well, hang on, what's the smallest number that 30 and 4 both go into? 60. So if you wanted to, you could say, well, let's make this over 60. What did I have to times this by to get to 60? 2, so that would be 46g. What did I have to times 4 by to get to 60? You are correct. 15 times 2 plus 3g. Now, this is the whole premise with the cross multiplying. What you're technically doing is you're getting it over the same denominator. So if this over 60 equals that over 60, don't the numerators have to equal each other? So you could just go, okay, now I'm going to ignore the 60s. So that has to equal that. Now you might be going, hang on, they're different numbers. Why are they different? Because here we haven't gone the lowest common denominator. Here we have. You are going to still get the exact same answer. So even though I said, let's not finish it, I will finish this for you just to show you that you get the correct answer. Which way is better? Whatever works for you. Yeah. So yeah, I just heard it's crazy you get the same answer because, you know, you're doing everything correctly. It's just this had bigger numbers because we didn't go lowest common. We just went cross multiply. Here, it irritates me having to do that fractiony thing. You could have just asked yourself, what do 30 and 4 both go into, you know, and do that, whatever you had to times by. Does that make sense? Bit tired of writing, then Your dreams are coming true, because with this one, I'm hoping you go, I don't need to solve too much of this. What would you do with this? First thing that you would do.
Common denominator.
Yeah. So before common denominator, look and always ask yourself, is there something I can simplify first? So why don't we simplify that, and that would then be 5u plus 5 over 6 plus 5u plus 10 over 9, and that's going to equal, get rid of the plus 2, take 2, you get 5. And now this just becomes like the other questions we have done before. Agreed?
Yes.
Right? If you had not done that, you're making it 3 bits and pieces. It becomes harder than it needs to be. So always see, can I simplify anything first? It's the same, Finn, when you asked about here, can we add these together? Absolutely, do that first, because if you didn't, you would have had to gone 4 times that, 4 times that, and you're doing extra work. So I'm not going to finish that one, if that's okay with you, because it's just the same. I will just ask you, what's the common denominator you would use? 18, you absolute champion. Okay, so again, I don't think we need to finish these ones, but explain to me, what would you do here? The trick is, oh my goodness, there's now a pronumeral as a denominator. Ooh. Fletch, what will you do? Absolutely. We don't like this divide by k, so you would just times by k. So we've got 3k minus 45 equals 2k, and then away we go. Yep, get your k's on the one side and you're off and running. Correct? I'm not finishing them now because I think we all know how to do it. Okay, what about this one? Ooh. I will find when you're doing an oral presentation, and I'm going to come and watch.
Left side or right side? Right.
Shh. So, what do you want to do? Sure, you could. And look, again, there's no right or wrong. So Leon was just going, put that over 1 and then get the common denominator and do the same. Absolutely, you could do that. So I'm going to get my, I'm going to put my numbers together. And I thought, oh well, while I'm here, it was up. So you could go. I'm not going to redo that. I could have gone, yeah, don't like that. I want to go on the right-hand side. So she kept her a over 5 where it was, right? She said, let's get rid of this take 1 and add 1, so it's 5. Huzzah. And then this comes over, so that's minus. Now, that just means, oh, you're going to have to use the brackets and whatever, but you'll get the same answer. Right? Miles might have left it right at the beginning and gone over 1 and zoopy doopy. Hamish, you might have gone, what's the number that 5 and 2 both go into? 10. And so you've times everything through by 10. So you would have got, so times every single term by 10, and you can go 2a take 10 equals 15a take 5 plus 40. Right, exactly. I think that is a bit tricky. Right, I've times that. What's the number 5 and 2 both go into? So times 10, and you have to times everything by 10. What does 2 go into? Oh. So times that by 5, and you'd have to times that by 10. Shh. So that's why I'm saying I don't want you to do all the way to the bottom of the jar like that. Break it up, break it into bits and pieces that you can do, and then away you go. Okay? So I think you've reached your point of no return now. Who's got your graphic calculators in front of them? I confused you in the last one. That's all right. Just going to remind you, go into normal run mode, option, calc, solve n. And when I say remind you, I suddenly realise you're year 10, so I'm not reminding you. I might be showing you this for the first time. So imagine if we had x plus 7. So that's my x there, just adding it in. Where's my equals? Above the decimal, equals 10. Now I know my answer should be. So enter it. Yeah. 3. Solve n. You can enter fractions in. Okay, so you can put 2x take 6 over 7. Oops, make sure you put the 7. Equals. Give us one. Oh.
Close the brackets.
Why is my... And so on. I'm going to get that on video. You probably heard it from here. It was a bit loud. And that's pretty. I'm pretty impressed that came out as a whole number, not a decimal. That doesn't happen very often.